Hello, my name is Rafa Vok and I'll be doing a demonstration of the load cell design the group Gigabytes have built. So here's the design. It's already plugged in, ready to go, and we have our known mass, which is a kind of monster. So first of all, let's weigh it on a real scale. That is definitely much better than this. So that's in grams, so it's 522 grams. So we should be getting around on our actual load cell, we should be getting 0.52-ish, because our load cell is set to kilograms as a unit. So as we can see, you should see it in a second there, the weight is 0.567-ish, and that would be correct. As we can see, I drew a quick table here. So load cell is giving out 0.009 volts because we're using a 9-volt battery. This, I know I'm skipping a couple of steps here, but basically our differential amp has a gain of 10. That brings to 0.09 volts. A non-inverting amp, which is a gain of 11, because it's gain of 10 but it's plus 1. Like, non-inverting amplifier has 1 plus the gain. So it gives out almost exactly 1 volt, which is very nice to work with. It's very easy. So it's 0.99 volts, which is basically 1 volt. And we know that Arduino is a... Sorry for that cut there. It's actually... the Arduino is a 10-bit system. So it's... it basically gives... For 1 volt, it does 204.6 digital units, which is what we're putting in. 1 kilogram is 1 volt. Yeah, pretty much. So we should be getting in the serial monitor, if we look at it, so we're looking at 0.55, and the actual scale was giving us 0.52, and if we multiply that by 204.6, we should be getting the digital units we should be seeing on the serial monitor on the laptop. So 106 around digital units, and that's around what we're seeing. The precision is not great, but we're very close. We're off by 6 digital units, let's say, something like that. And yeah, let's try with different weights next. Oh, also before I move on, I can actually check the voltage we're getting. So at this weight, which we had at 0.52 kilograms, just hold on there a second. So I'm looking at the output of the non-inverting amp, which is the input to the analog pin of the Arduino. So we're getting 0.54, 0.55 volts, which is pretty much what we should be getting, because as you know, 0.55, how can I prove this? Oh yeah, 1 volt, 0.99 is the weight at 1 kilogram. That we should be getting that voltage at 1 kilogram. So at 54 kilograms, or 54, 0.54 kilograms, we should be getting 0.99, pretty much 0.53, which checks out. We're pretty much correct. So by changing the mass, basically by drinking the monster, I have made a random weight now. I don't even know what it is at the moment. Let me turn on the scale and let's weigh it. It's about 0.36 kilograms. So that's pretty much what we should be getting on our load cell. output. Make sure that doesn't actually wiggle because that can compromise our readings. So if you look at the output real quick, so we're getting 0.36, and that's very close. That's almost it. So it's 0.36 kilograms. So at that point, we can calculate what we should be getting at the digital monitor or serial monitor. So 0.36 by 204.6, and that is 73 digital units. So let's have a look, and that is indeed what we're getting. 71, well, we're off by 2 digital units, let's say, but we're close. So yeah, the system seems to work very well. Let's try one more weight at a bit lower value. I'll be right back. So I've reduced the weight even further in a very scientific way. So let's weigh it one more time, and we're getting just above 300 grams, which is 0.31 kilogram, let's say. And let's check it one more time. So we're getting around 0.31, 0.29 kilogram there, which works like a charm, because then let's check the voltage at the non-inverting amplifier there. So to get that, we get 0.009 by 10 by 11, and that gives us 0.99, and we multiply that by 0.31, and we should get 0.30 or 0.31 at our differential op amp. Just 1 second there, it's very hard to do it on my own. Alright, so we're looking there, and as you can see, we're getting around 0.26, 27 maybe, which is a bit off, but it's reasonable. It's very reasonable. At least it's working. It's working pretty well, if you ask me. I think this project has been a success. We have made it work, so thank you very much. Goodbye.